All right, welcome back, class. This will be Unit 7, Lesson 4, Balancing Equations. So to start, we're going to review the distributive property, and when we distribute, we're going to distribute this whole to each piece. So that becomes 3 times x plus 3 times 3, and then we can multiply. So that's 3x plus 9, and we multiply each piece, and then that would be simplified. And that's what we'll be doing here while we're reviewing. So first, it's -4 times 2x, and we have plus a -4 times -3. That -3 can stay with it, and we're adding them together. So when we multiply, we have different signs. So that'll be a -8x. And in this case, we have the same signs. When we multiply, it'll be positive. So it'll be -8x plus 12. Distribute to each piece. So that's 2 times 3x plus 2 times a -6. So 6x plus a -12 because the signs are different. And then one more here, when we distribute to each piece, we get -4 times x plus a -4 times 5. So that's -4x plus a -20 when our signs are different. In both cases, signs are different. You get a negative out. Okay, so how do we balance scales to help us understand equations? Let's do the same thing we did yesterday with now some distribution is the first step on the left. We're going to distribute the 3 to each part. So it's 3 times 2 plus 3 times 1 plus 1. So we can multiply left to right. So we get 6 plus 3 times 1 is 3 plus 1. Since addition is both associative and commutative, you could add any way you want, but I'm going to add left to right. So I get 9 plus 1 is 10. So my right side should equal 10. And let's check. So we have 11 minus 1. I'm going to rewrite it. It's a difference. The positive sign is greater than, so it's going to stay positive. And the difference is 10. And so that's good. 10 equals 10. That's what we wanted. So when it says or asks, is the expression balanced? Yes, it is. We verified because both sides of the balance scale here equal 10. Now, to make this scale balanced, the left side must be the same as the right. They must be equal. So on the left is 2x. So each one of these represent an x. On the right, we have equals 4. 1, 2, 3, 4. So when we look at it, we'll have x equals 2 because this x equals those two to keep it balanced. And again, you could check with the bottom one too. It'd be the same thing. X equals 1, 2. And now we can substitute and evaluate. So just like when we did substitution, we can plug in 2 for x. So we have 2 times 2 equals 4. Well, 2 times 2 is 4, so that's true. So x does equal 2. Now we're going to do it again. We're going to balance the scale using substitution. We want to get the x's on the left and the constants, everything else on the right. So what I'm going to do is going to do a negative here. If this represents a positive, we'll say that this represents a negative. And what you do to the left side to keep it balanced, you must also do to the right side. So again, over here we have a positive and a negative. And so the positive and the negative here, those will cancel or simplify to just 1. And on the right, they will simplify. So now these big green pieces are still x because we have 2x. And on the right, we have 1, 2, 3, 4. So we have, again, x equals 2. And it says balance the equation using substitution. And that's what we did. We substituted some pieces in. Balance the scale using substitution. So we want all the x's, or these green pieces, on one side, and all the blocks, the constants, on the other side. So because I have more x's on the left, I'm going to bring this one over. I'm going to bring them all over there. So that'd be a negative. So I have one negative over here. So that means these two will simplify and those two will simplify. Now I want to bring this yellow one over to that side. So that way. So those will simplify. So in this case, we have an x equals 1. X equals 1. Let's substitute it and check. So it's 2 times x. X is 1. Plus 1 equals 1 plus 2. 2 times 1 is 2 plus 1. On the right, we have 3. 2 plus 1 equals 3. Okay, good. Yes. So we balanced the scale, the equation, using substitution, and we verified. When x is 1, these two expressions or equations are balanced. All right, now you try. And if you have any questions, let me know. Okay, thanks for watching.